Okay, today we're going to be looking at composite functions. Now, most functions can actually be described as a composite function, as a combination of two or more functions. So let's think about the function x, which has been mapped onto 3x minus 7. So this is a function, multiply by 3, then subtract 7. It's actually a combination of two functions, g, so function g is x multiply by 3, and function f, which is the function subtract 7. So x is function 3 multiplied by 3 subtract 7 can be described as first do g, then do f. So let's see, we've got x here, and then first we're going to do g. This is g of x, so we do g, which is the multiply by 3. Then we do f, which is subtract 7. So then we have f of g of x. So f of g, which is the composite function. We call this a composite function when you've got a combination of two functions together. So f of g of x means the function g acts on x first, then f acts on the result. There are three important points to remember when we consider composite functions. So firstly, f of g only exists if the range of g is contained in the domain of f. So if you had x and then you act on it to get g of x. Now remember, this is x and this will be g of x. So this here is the domain, and up here would be the range. Now when you take g of x and then apply it to f, function f of x, that range now becomes the new domain. So f of g only exists if the range of g is contained in the domain of f. In general, f of g of x will not equal g of f of x. There are exceptions to this rule, but in general, the vast majority of cases, they will not be equal. F of x means you apply the function f twice. So let's look at some examples. So let's consider f of x equals x minus 4 squared minus 1 for x belonging to the real numbers, and g of x equals 2x plus 3 over x minus 2 for x, remember, real numbers, and x greater than 2. So let's find the function f of g4. So what we would do is we apply the function g of x first to x, where x equals 4. So we're going to take g of 4 first. So that's going to be 2 times 4 plus 3 over 4 minus 2. And working all that out, you're going to get 11 over 2. Now we take the result here and we apply it to the function f of x. It's going to be f of 11 over 2. So 11 over 2 minus 4 all squared minus 1 is going to be, if you work it out but keep it in the form of a fraction and then put it into a mixed number, you're going to get 1 quarter. So that would, you do like, I'll just do a quick working here to show you. 11 minus 8 over 2 squared would be 3 over 2 squared, which is 9 over 4, and then you're going to minus 1 there, and you're going to end up getting that. Okay, so let's now look at f of x equals to 2x plus 3 for x is a real number, belongs to all real numbers, and g of x is x squared minus 1 for x belonging to all real numbers. So let's firstly find f of g of x. So we take f of x squared minus 1. So where we see on f of x the x, we're going to substitute the x for this. Just in the same way, say if it was f of 2, where we see the x, we'd put a 2. So here we'd have 2 x squared minus 1 plus 3, and we're going to expand the bracket, so it's going to be 2x squared minus 2 plus 3, 2x squared minus 1, plus 1, sorry. So now let's do g of f of x. So we have g of, so f is 2x plus 3. So here is what the x part is, this is, so we're going to apply this to here. So we're going to have 2x plus 3 squared minus 1. We'll expand this. So I'll do it over here. 2x plus 3, 2x plus 3 going to become 4x squared plus 12x plus 12x plus 9 4x squared plus 24x plus 9. So over here, and then you're going to take away the 1, so we're going to have 4x squared plus 24x, 9 minus 1 is plus 8. There we go. And lastly, we're going to do f of x. So we're going to take f of 2x plus 3, which will be 2, 2x plus 3 plus 3. So it's going to be 4x plus 6 plus 3, and that'll be 4x plus 9. There we go. Let's do another example. So this time we've got function f x is 5 over x minus 2 for x, remember, of real numbers, but x is not equal to 2. And we're going to have g of x equals to 3 minus 2x plus 2, 3 minus x squared, 4, sorry, x belonging to real numbers. Now this just shows you they're just mixing notations so that we can see that the notation doesn't matter. So first we're going to find f of g of x. So that's going to be f of 3 minus x squared. So in here we're going to substitute x for 3 minus x squared. It's going to be 5 over 3 minus x squared minus 2, which is going to be 5 over 3 minus 2 is 1 minus x squared. And then we're going to do f of x. So that's going to be function f acting on 5 over x minus 2. So we're going to have 5 over 5 over x minus 2 minus 2. Now we're going to deal with this bit here. We're going to multiply the numerator and denominator by x minus 2. So we'll have 5 x minus 2. Then here we're going to have 5 minus 2 x minus 2. Let's expand all these brackets out, so it's going to be 5x minus 10 over 5 minus 2x minus 4, which will be 5x minus 10 over 5 minus 4 is 1 minus, wait a minute, plus. Is going to be 9 minus 2x. There we go. And we will do one more example. So for f of x equals to x squared plus 4x for x belonging to all real numbers, and g of x equals to 3x minus 1 for x belonging to all real numbers. We want to find the values of k for which f of g of x has real solutions. So let's do f of g of x is going to be function f 3x minus 1. So it's going to be 3x minus 1 squared plus 4 3x minus 1. Let's expand the brackets out. So we will have, I'm not going to do all the working, so expand out, expand, and simplify. So that's easy enough to do. So 9x squared plus 6x minus 3. So when f of g of x equals k, so 9x squared plus 6x minus 3 equals k. So we're going to take this over and we're going to rearrange it. So x squared plus 6x minus 3 minus k. Now this is going to be a constant term. Wait a minute. So I want to, yeah, I'll just wait a minute. I'll show you what I mean. So 9x squared plus 6x plus, so I'm going to put this number here, equals 0. So this is like the term at the end of our quadratic. Now we're going to think about if a quadratic has real solutions, we look at the quadratic equation, we'd have b squared minus 4ac must be greater than or equal to 0. So that's going to be 6 squared minus 4 times 9 times minus 3 minus k. So it's work all this out. So we'll have 144 plus 36k greater than or equal to 0, and that would give us k greater than or equal to minus 4 for that function to have real solutions. So I hope that helps.